In this video, I'm going to be discussing about exact differentials. Now, if you have an expression that, let's say m, but this one having variables x and y, plus, then we are having our n having x, y, right? But this is, let's say we have here the x. Let me remove the whole of this. We have m, have x, y, from in terms of x and y. Now here we are having the x plus we have n, x and y, right? This one we have the y, the whole of this being equals to 0, right? Now the partial derivative of m with respect to y equal to the partial derivative of n with respect to x, right? Now, if they are not, that means that the differential is not exact. So, and therefore, if we get, let's say, like partial y not being equals to partial n, partial x, and this is not equals to this, then that differential is not exact, right? So, for it to be exact, this must be satisfied, right? Now, let's use an exact example. For example, if I have 3x squared minus 2y squared, this is the x, plus have 1 minus 4xy, this is the y, and this is equals to 0, right? Now, this is in form of m, x, y, this is the x, plus we have 1 minus, this is n, x and y, this is the y, and this equals to 0. Now, the partial derivative of m with respect to, this is y, will be equals to, if you differentiate this with respect to y, we shall be getting, now, if you differentiate 3x squared with respect to y, you get 0, right? Now, this will be negative 4, right? Y. Now, partial derivative of n, this is with respect to x, right? This will give me, if you look at this, if you differentiate 1, you're going to get 0. And if you differentiate this, you're going to get negative 4 respect to x. That means that you're going to have y, right? Now, if you look at this carefully, partial m respect to y is equals to partial derivative of n, right? And this is equals to negative 4y. And therefore, the differential is exact, right? To get the general solution, you're going to get, let's say, the integral of m with respect to x, right? And then what you get from there, you want to get is what you get from here, then you differentiate it with respect to y. Let's do it. Now, if we integrate, our m was 3x squared. We had 3x squared. Let me copy the whole of this. 3x squared, right? Minus 2y squared. 2y squared plus this. We're integrating this with respect to x, right? Now, we're going to have here something that's going to be, we're going to have 3x cubed over 3 minus 2xy squared, right? then plus our constant. But our constant this time will appear in terms of y. So it will be g of y. Right? Now, differentiate what you've got with respect to y. Therefore, partial, let's say with respect to y, we shall have here, this is x cubed minus 2x y squared plus g of y. Now, this will be equals to, differentiate this with respect to y, this is going to be 0, right? Now, let's differentiate this. You're going to have, respect to y, you're going to have 2 times 2, right? X, y, right? Now, plus, if you differentiate this, you're going to get, first, let's say the first derivative, so it will be g prime of y, right? Therefore, we are going to have something that's going to be 4x, y. Remember, there was a negative, so this is negative, right? So we have here negative plus g prime of y. And therefore, this must be equals to n. And therefore, we compare, right? Now, for our n, right? X and y, for n, xy was equals to, we had something that was like this. It was 1 minus 4xy, right? So if we take this side, let's put it this side. That was our n, right? Now, what we have got, let's say, as our derivative has to be equals to this, right? Now, our derivative with respect to y was negative 4xy plus g prime, right? G prime of y, yes? So, let's apply this side. That means that negative 4xy plus g prime of y must be equals to this 1 minus 4xy, right? Now, if you compare them, that means that negative 4xy is equals to this, and then g prime of y must be equals to 1, right? That means that g of y is equals to y if you integrate, all right? Then our general solution now, which c, will be equals to what we integrated initially, right? Of which in this case, we got something that was this. We got this after integrating. But now we are going to replace, let's say, g of y with y, right? So x squared, x cubed minus 2xy squared plus g. So we are taking this. So in this case, we're just replacing this with y because g of y is y. And therefore, this is our general solution for this problem. Now, let's try another example. If we have 2x plus 3y, this is the x plus 3x plus 4y, the y equals to 0, right? So here what we are going to be having, let's firstly prove whether this is exact. Now, partial m with respect to y, we are going to say that this is going to be equals to, now, with respect to y, we are going to have 3. Now, partial n with respect to x, we are going to have, if you differentiate this with respect to x, we are going to have 3, right? Now, therefore, this is exact, right? Now, we are going to integrate integrate 2x plus 3y with respect to x, which this will give us, you won't have, this is going to be 2x squared, which is going to be x squared, right? Then plus, this is going to be 3xy plus our constant, which is going to be in terms of y, g of y, right? Now, differentiate this with respect to y. So partial x squared plus 3x plus g. Oh, this is okay. This is, let's say we're having partial of x squared plus 3xy plus g of y. This is with respect to y, right? This will give us something that's going to be, this is going to be 0. We have 3x, right? Plus, we are going to have g prime of y, right? Now, you compare this to n, right? Of which our n, we had here 3x plus 4y. We had 3x plus 4y, which will be equals to 3x plus g prime of y, right? Now, if we compare these two, find out that 4y will be equals to g prime of y, right? And for us to get g prime of y, this will be equals to, oh, it's a repetition. So for us to get g, that means that we have to integrate this, which will be 4y squared all over 2, which will be equals to g of y, right? Therefore, 2y squared will be equals to g of y. Now, write down the general solution, of which our general solution will include what we integrated initially plus our constant. Our constant is 2y, so this will be equals to, I can say that this is 2y squared. Then, what did we integrate initially? We integrated and got x squared plus 3xy plus g of y, right? So this is plus x squared plus, we had here 3xy, right? So this is the general solution for such a problem. Now, let's do another one. Now, this time let's have an exponential. If you have 2xy plus e of y, this is dx plus x squared plus x e of y plus 2y. This is the y, and this is equals to 0, right? Now, what we are going to do here, let's prove whether it is exact. Now, let's say that, let's say the partial with respect to y of 2xy plus ey, this will give us something that if you differentiate with respect to y, we are going to have here, this is going to be 2x plus e of y, right? Now, let's look at the second part. Now, want to differentiate in partial. This is partial x, let's say, of x squared plus x e of y plus 2y with respect to x, right? And therefore, what we are going to have here, this is going to be 2x, right? And then plus, if you look at this, with respect to x, we're going to have e of y plus, with respect to x, this is going to be 0, right? And therefore, our overall derivative for this is going to be 2x plus e of y, right? Now, if they are similar, that we are going to have, that means that if partial m respect to y is equals to partial n with respect to x, and these both give us 2x plus e of y, and therefore this differential is said to be exact, right? Now, to get the general solution, we have to integrate for m, right? Now, for integrating n, we are going to have 2xy plus e of y. So 2x plus e of y respect to x, right? So if you look at this, we are going to have 2x. It was 2xy. Yeah, there's a y missing here. 2xy plus e of y. So therefore, this is going to be equals to, you're going to have with respect to x, we're going to have 2x squared y all over 2 plus respect to x, this is going to be 0. Oh, you're going to, not 0, we're going to have x e of y plus our constant that's going to be in terms of y, which is going to be d of y, right? Now, that means that the overall solution would be x squared y plus x e of y plus d of y, right? Now, differentiate this with respect to y, right? You're going to have x squared y plus x e of y plus d of y plus this, and differentiate it. When we differentiate that, if you differentiate this with respect to y, you're going to have x squared, right? Now, with respect to y, plus x e of y, right? Now, plus d prime of y, right? Now, whatever that we have got here has to be equals to n. Now, let's find out that x squared plus x e of y plus d prime of y is equals to, what is our n according to this, right? That our n previously was equals to, we had x squared plus x e of y, we had x squared plus x e of y plus 2y. If you look at this from here, right? Now, that means that if we are to compare, that means that d prime of y is equals to, take this out, we are having 2y, right? That means that d of y is currently giving us 2y squared all over 2, which is going to be y squared, right? Then write the general solution for this. Therefore, we are going to have, we can say that the general solution will be y squared plus what we integrated initially. Yes, we integrated something that was, we had x squared y plus x e of y, right? So we are taking the whole of this. We are taking the whole of this. For this page. Yes. Now, only we have replaced this, right? And therefore, this would be the general solution for our problem. Now, thank you for watching. See you in the next video.